after the break. We are 7 minutes delayed, but that's all right. So I'm honored to present Erik Torstensson from Sweden. He's here to talk about making a toy for makers, and I look forward to this very much. Erik, you're on.
Thank you so much. Thank you. It's it's incredible to be here. Oslo has been this is where all the ideas get born of our making thing. So today, making a toy for makers. So there's all of these words here on the screen, like a toy, defining a toy. What is a toy? And then you define what is a maker. And you know, basically everybody is makers. We had one of the worst things that we saw last year's, the latest Maker Fair, was where they defined where these kids, are you a maker was the question, and there was a test to see if you're a maker or not. One of the worst installations I've ever seen, because basically everybody's makers, you just haven't been enabled, you haven't been in contact with it, or you know, it was crazy. But anyway, back to the happy part, is that you know we are basically all makers, so we just need to get it started. So I'm going to show some of the things that I think started me into the maker thing. Everybody has one thing in common in here, I think. How many of you had a Lego set? Yeah, a lot of hands. I would venture to say that was 100%. How many of you think that affected a little bit of that you're sitting here today? Tiny? That was a little bit, you know, a little bit. If we say it might have impacted that you're here, yeah, then better. Cool. For me, I think it was crucial. I had we weren't that, because my dad was an entrepreneur, so we didn't have a lot of money when I was growing up, so we got to inherit toys. And one of the few toys that worked to inherit and looks just as good on the second generation as the first generation are Legos. So I had a lot of Lego Technics when I was way too young, with all these wonderful instructions. So that was crucial. Second thing is this fantastic thing. I didn't get one of these. Does anybody know what it is? This is a brilliant, like, maker toy. This is a programmable car. And I saw it on the TV because I grew up in London. So I saw it on the TV all the time. You could program 16 steps and just play around with it. So that's my first venture into coding. Second venture was just like Utus of Atmel said yesterday, that the Amiga got you into like tinkering with things and understanding the code, starting to just make random stuff. I actually had a ZX Spectrum before that, you know, basic 10, hello, 20, nothing, 30, again, go back to 10, and you know, go to 10. It was fun, so I learned that. But then there are all these things happening now. Like, I would like to call this a toy, because this is a toy that enables us as makers to start like playing around and figuring things out. But the reason I came into that was this toy. So you recognize this? Anybody in here? You said it's the Makey. It's been like poster boy or poster girl or poster thing for the maker movement too. And the banana piano was an epic success in terms of YouTube content, stuff like that. So I'm actually friends with Erik. I stay there when I'm at MIT talking, so I love this piece of kit. The thing was, that pulled me into this. So this is a maker toy, because a maker toy makes new makers. It gets you into that thing, that entire area. So that's when I started like fiddling with Arduinos. Then you get a lot of power, and with great power comes great responsibility. So the first thing I did is the smoking Santa for my mom. So it's just a roll of paper. It's not a cigarette, but it looks very realistic. It's just an LED in there, and you have to light it up with a flashlight, because it's an LDR and an LED, and a little bit of code that makes it look like it's glowing. So that's one of the first projects actually it was from when we had a workshop in Tenerife. I was holding a workshop in Tenerife about Arduino and coding, teaching myself at the same time, which I think is the best way to hold a workshop. It's amazing if you have the guts to do that weird kind of stuff, and sometimes I have that. Other things like toys, the definition of toys. One of my other favorite toys are all these wonderful little synthesizers that Korg has released. So Korg is one of my old, I play music, so I use these old analog synthesizers. But what they do is they released all their schematics and all their circuit boards, this is a really bad picture, have the patch points printed out. So if you take it apart, you can go in and solder on a bit of cables, some extra knobs and stuff, and then you have a much more powerful synthesizer. Other things it does, it makes these really inexpensive, tiny, this was, actually I brought the Vulcan, I'm gonna play a little bit with it later. But this, you can see a small toy, this is a 200 kroner, 250 kroner synthesizer. I don't know how many of you know about this, but it's called the Monotron. And this is the Monotron, the Duo. Anyway, with the Arduino and the open schematics, all of a sudden you have control. You can build crazy stuff. So I built a cardboard sequencer with some knobs, an analog sequencer, took out the soldering points for the VCO, the voltage controlled oscillator, and then yeah. We can go on all day. I understand. You don't want it to end. Such a beautiful piece of music. I think it's the first time ever it's been played in front of an audience. The only audience in there is we have a showroom dummy. But anyway, what I want to say about this is the toys that I've seen, they foster curiosity. They want you to start playing around with stuff. They're a platform for exploration, which I kind of define as they're actually open so you can start tweaking them and start learning something else. They're just one step on the way to something. You know, it's brilliant. And they help other things. But most of all, as you've seen with all these things, they're fun. So I'm going to show you how much fun I have with this. And then we're going to have a little intermezzo here. This is interaction with humans. So we have different systems. I think you got that. And so this is one of the synthesizers that I opened up before. But this one, now it doesn't have any patch points. But basically, it just sounds amazing.
So, I'd like to tell you about the year 726, when the Byzantine Emperor Leo III announced the iconoclasm. So the iconoclasm is the systematic destruction of holy portraits. Because he realized that if people had a picture of God in their home, they didn't have to leave their home to feel meaning, to get in touch with that holy thing. And in the last 100 years, as religion started fading and capitalism came in and consumerism came in, we learned to consume meaning. We learned to consume culture. As Aldous Huxley said, in the age before machinery, we were forced in our humble ways to be artists. Now, people sit and watch as professionals entertain them through the aid of machinery. It is difficult to believe that general artistic culture can exist in this atmosphere of passivity. But this technology, this foreign thing, it's something utterly human. It is something that allows us to connect, that allows us to create. It's something that allows us to reclaim that ability to create what is holy. We can create our own mystical experiences, our own feeling of flow or nirvana. That moment where future and the worries about the future disappears and the regrets about the past fades away and you're only in the eternal now and you are tinkering.
Thank you very much, Gustav. Who is, we have one guy in charge of what we're doing. We have one guy in charge of how we're doing it, our CEO. We have one guy in charge of why we're doing it, Gustav Josefsson, our company philosopher. So, I'd encourage all startups to have a philosopher. So, what we set out to do now, and what we're going to talk about the last minutes here, is our goal was to make an educational toy that had all these values that I tried to communicate in weird ways here, that completes other systems also. Instead of just competing with them, it completes them and enhances them, because I come from the green background, we want something to make all the other things you already have better and add something. And hopefully if you can make it too, that's amazing. So I'm going to show a little bit of the background of this project that you've seen laying around, and we're filling it around everywhere. This is the background. This is me in India, where we gave away a machine to a school there, so they could actually make things out of the waste. We made cardboard structures. We made clothespins that we figured they need, because solar drying is massive in India. So we figured we're going to revolutionize the clothespin industry and let them make them themselves. This is what they did. The clothespins have not once been used as clothespins. They got turned into this construction toy. So that's actually what fueled us. We have to make an even better construction toy. This wasn't bad because they built huge, weird structures where they didn't actually have to. Basically, if there's a point where you can put something, you can continue there. So that's the system of this. But that fueled something, and then we were in contact with a couple of science centers, and we had the machines, we had all these experiments, and they asked us if we couldn't do something that we could build in 3D space with, and that worked. And fast forward, because it's a long, you don't want to hear the long thing about random, because 1.5 years of I don't know, and then this happens. This weird little pacifier shaped thing. And now I think, how many of you have seen it and tried it already? So, okay, everyone. So I won't go through the demo, but usually I do this fun thing with this, you've seen it. Should I do this simple demo of the magic of the strawberries? So while I'm taking these out of the sheet, I can tell you about where the name's from. So it's from last year's Maker Faire in New York, because then we had this little thing, and we called it the thingy. We don't know, we don't have a name. And we were asking everyone, what should we call it? What is it? And this one guy, Chris, I think it was 9 or 10, just said, hey, they're strawberries. They're strawberries, because they connect straws and they can be anything. So, yeah, he nailed it. He's our copywriter now. So sometimes child labor can be denied. But anyway, did you see, I was just talking, I was more like a magician trying to detach from take away attention from this. You make struts, you connect the struts with the same part. Everything is just one part, which is the lucky thing in this project. And then you can connect them mechanically and build this flippy floppy, fantastic straw. You've never had a straw like that. Anyway, not so good for drinking, but that's another thing. But it has this other fun function, which is if you want to, for example, build a tree or a structure like this, copy it directly, take all the dimensions, build, attach more and more branches, then you can fold it over like this, and lock it for friction, and then you have this angle. So now we have this straw. The 75 weird angle thing. So this, carry on, we just tried it out everywhere. This is in Oslo Maker Faire this January, where it actually had the name. And we won prize for best mess. And this girl came up to me and she asked, "Hvordan lager en et blad?" which means, how do you make a leaf? And I kind of tried to just avoid the question, but like enhancing, like encouraging her to figure something out at the same time. And Dale Doherty was standing just next to me. Then she walks away and just continues, you know. Comes back with this. And I love it. This is when this was, I think this was the greatest thing at that Maker Faire, when she just hacked it. You know, we don't need a connector here, we can just bend it. And it looks amazing. So that's the thing, it enables her to figure out her own solutions without us ever telling her to do so. It was basically me kind of, while acknowledging her, kind of turning my back slowly so I'm not scrutinizing her so she figures something out. But then we started with the curriculum, so this is what's happening now. We're teaching kids how to reverse engineer everyday objects. So this is a lamp, you know, a regular lampshade, like a table lamp. So they can copy everything just as it is, which actually, in our mind and in my mind, it opens them up to see, just like in Harry Potter, there's all these secret things. But in our book, it opens up the everyday mechanical world, and they see the stuff and how it works, and can actually start copying it. But they need to get a little bit more comfortable with actually experimenting to do this. But they're better at that when they're 6 than when they're 12. So we want to like get them to stay in the mode of 6, 7 years old for as long as possible. I'm still there, basically. And it also connects, you know, cardboard. So this is a really fancy pants cardboard boomerang. Unfortunately, there are all these lights here that might die if I throw it, but it would come back. It would come back, but we can try it outdoors later, and everybody who wants to can come and make one if you find the cardboard. Should we try it? Okay, I can go below here. Yeah. And it's actually one of the best working boomerangs I've ever had. You've seen that we've tried this out. Every time we make them, they fly. And then this is the best part about this boomerang. You just modify the characteristics and try it again and see how it flies. You change the flight path, but it comes back. So this is what we call sciencing. So the kids do this, and they take note of what happened, film it, because that's sharing the knowledge, so others can build upon what you built and make the same thing and maybe improve upon it even more. So, and this is the mess after that photo session. I just wanted to show some internal photos. Comes to cardboard. This is the Kids Hack Day. We had a mashup with Kids Hack Day, which I'm going to talk a little bit more about. We're almost there with the end, but it was a little bit delayed. But anyway, this was an amazing little suit. So I'm going to see here if we can start this animal up. Oh, I forgot to switch the sound system, but yeah. It has all these animatronic qualities, but we were fiddling around helping the kids, but just building fancy costumes. So the Strawberry story was basically, we did everything. We tried it. It's open source. You can just copy it. You can download it. You can cut it out with a vinyl cutter. The only thing we have is the brand Strawberries. So you can't use that without talking to us, making sure that things work. We had a Kickstarter, went really well, which actually opened up an even better community for us. And that's much thanks to Gustav, who had the philosophy of how we were supposed to do the Kickstarter and why. So that was great. And now we're just traveling around making chaos. But one thing that I put this slide in because we were talking about the different people playing with the things. You know, how can we attract, in this case, the mix is really nice because here they just took over the space really fast, this gang, but these started like hovering, getting closer, hovering, and then in and building. But it took a while, so we have to mash these kids up too. So, what's happening now? What's happening when you have this open source system? You're taking a lot of risk because we're just giving it away. I didn't know how good it was when I took that decision, by the way. But you know, that's even better now because none of these amazing things would have happened otherwise. So one thing is we have what people think is a copy in Taiwan, but it's not a copy. It's the official copy. It's a collaboration. So we're actually looking for new names. But what he's doing, Strawberries Taiwan, is amazing. He's building this entire curriculum He's sorted out how to injection mold it, and he's part of us now, so he's part of the team. We recruited him through this, and what they're doing is a book. So this is secret. So I'm showing some really secret stuff here. This is a story about a little mouse, or a little ferret of some kind, and he's sitting in the classrooms watching the kids building with strawberries all day, and then in the night he tries to replicate it, and he's just fumbling around because nobody sees, so he can try out all kinds of wonderful solutions. So he's like this little tinkerer ferret. And one day a bird flies into the window and hurts his wing. So then he has to solve that. So he goes through all Da Vinci's old sketches. He starts mocking up different solutions. And this is him trying it before he puts it onto the bird. An amazing story. The content is so amazing that we just, whoa. This is way better than anything we'd planned. So this is why you should go open source. And this is also one of their photos. This is like the crazy elephant thing. Because I had somebody asking me, these straws are useless, the bendy straws. But they're amazing if you want to make an elephant. So it's always different things. But the end, the toy has been working well. We've been trying it out, especially with our friends at Kids Hack Day, where we've been part of actually starting that up too, just by being there since day one, unofficially making things. But so now comes the kid invention through actually taking it out to all these places, building with it. What they did in Sydney was we had the Kids Hack Day in Sydney, they started putting straws onto LEDs, onto a little circuit board that had LEDs on it. So then Kalle and me had been talking, you have to make a product out of this. So we have this ecosystem of companies instead of just one company doing all the development. And then comes this magnificent creature. We found this out the day before yesterday. This is a very classical Swedish piece of industrial design. In here is the robot strawberry, the QuirkBot, which is a collaboration now that's just because it's open source. Otherwise, nobody would have started touching it and designing things with this, and we had to do it ourselves. But we had one meeting saying that we want something that you can squeeze on electronics, and then start building really, really shitty robots. So this is a very shitty robot, but it actually works sometimes. And so all these things happen when we did this system. So you just squeeze on LEDs, and then you light it up, and it starts working, and it does. Now it's working out. So it's doing a workout. And then so the other thing is it has 5 inputs, 5 outputs, and it works like a lot of different things. It's got lots of outputs, but it's got 5 legs. So what happens if you put a light resistor, and this is a photo transistor, I think. If you put that onto one of the legs, and then put an LED on the other end, and then control, you have a squeeze interface, where I'm just squeezing this straw that's so low cost that you wouldn't believe it. When we showed this at the World Maker Faire, they're like, what is this? Sorcery. And of course, that drives innovation. So now, if you look at this, we build this into a robot, it can actually sense which leg is being bent, or has been bent past a certain point. So imagine this is the leg of the robot instead. So it's walking around and somebody comes up and, breaks his leg. He knows this. So either you can make him actually light this leg up, so it says this leg has been broken, needs to be fixed. We actually have a backpack with a soundboard on so we can actually say this too. Ow, my left leg, it really hurts. I can't walk anymore, so we anthropomorphize it. These are things that kids really love when they drive it together with me. I am the kid in this case. So some of the kid design things are comes mutually. Anyway, this is the last thing we're going to show. We're going to end this with a little fun last demo of what the QuirkBot can do, because we had one design meeting together. And one of our friends just dove into a cave somewhere and developed this. And 3 weeks later, he had a prototype. And since then, we've been doing crazy stuff. But what this can do with the Atmel chip is it uses everything. So now we have a MIDI to USB device. Isn't this the sound cable? I'm pretty sure it was a sound cable before, but now it isn't. So what I did now is I connected it to it's not a keyboard, it's nothing like that. It's a MIDI device in here. It's the core gadget, amazing piece of kit. So you know the Makey Makey. It's the same, it has the Makey Makey things because we're friends with them, and it's an open source platform. It built a platform for us to do these things together with Jay and Erik. So now we have and I can actually start sequencing this. Wait a second. Oh. I'm a musician. So there we are. Anyway, just like the banana piano, we can play with that too. So it's all these wonderful things. So we hope that if you're going to make a toy for Maker, make it foster curiosity, make it a platform for others, like work with others, and most importantly, make it fun. Thank you so much. And I have one little thing to add. How many of you saw me talk at the Maker Fair in Oslo? Anybody? Yeah. So did you see the talk about the world's largest fractal? That we were talking about, maybe it's going to work? Do you want to see the conclusion?
Yes.
We actually have one of the collaborators here. Ole, stand up. So we are actually officially amazing. 1,200 kids, 17.2 meters, 4,096 pieces of plastic. And this is the world record for the largest Sierpinski fractal tetrix structure. So it worked. But it was we were nervous. Thank you so much. Yeah. Exactly, yeah.
Okay, thank you. Now we need 1 minute to clean up the mess.